to my channel, Code with Fernando. Today we're going to continue with Module 4, Code Reactive Concept and Behavior. Introduction. Reactive programming is more than just asynchronous data. It's a paradigm built on well-defined contracts that ensure efficiency, responsiveness, and resilience. So, we have three principles. What are those principles? The first one, lazy evaluation. Data isn't produced until requested. This avoids unnecessary computation and increases efficiency. Then we have call and hot publisher. Call. Each subscriber gets its own stream. It's like watching a Netflix movie. On the other hand, we have a hot publisher. All subscribers share the same stream. It's like watching TV the old way. Finally, we have backpressure, a critical flow control mechanism allowing consumers to signal how much data they can handle, preventing overloads. Lazy evaluation. Nothing happens until you subscribe. Okay? Even if you define a stream and change multiple operators, no data flows and no work is done until a subscriber subscribes for that. So why is laziness important? Okay, performance efficiency, resources, CPU, memory, network are only used when there's real demand. Safe composition. You can build complex multi-step pipelines without side effects. Nothing will execute prematurely. Full control by subscriber. The subscriber dictates execution, making system behavior predictable and testable. Let's think of a lazy evaluation like you can write all of the steps, but no ingredients are touched until someone decides to actually cook. Okay, let's continue with our code example about lazy evaluation. First of all, let's create a flux. Let's create a flux of string, of type string. Let's call this books as usual. Books. Let's just and let's call let's create some books. What about with this one? Clean code, effective Java, and finally design patterns in Java. Okay, now let's do on next method, and here just going to print the book, fetching the book. Okay, fetching book. Let's go. Okay, that's it. So if you want to see the books, I mean this one, and that one, we need to subscribe. Otherwise, nothing will happen. So it's quite easy just to call books, subscribe. Now it's a lambda expression. Okay, we have to create. Let's call this customer gets book. Okay, so first of all, we are going to see fetching book, clean code. After that, we are going to see customer gets and that one. Okay, let's see this in action. Good. Okay, let me create a space in here. Okay, let's see now. Okay, it's better. We are fetching a book, then the customer gets the book. Okay, we are showing an example how lazy evaluation works. Okay, because nothing happens unless you subscribe. Then we have call and hot publisher. Who controls the data flow? Let's begin by explaining call publisher. Data starts only when someone subscribes. Okay, each subscriber gets a full new copy of the data. This is good for reading files, running database queries, and calling APIs. Data is replayed from the beginning every time. A good analogy is, let's think of it like watching a Netflix movie. Each person watches from the start. Why is it useful? It gives more control to the subscriber, save resources, runs only when needed. It's easy to test and repeat the data flow. Then we have hot publisher. Data is pushed continuously, even if no one is subscribed. New subscribers only receive data from the moment they join. Does not replay all data. What's gone, is gone. This is really important. What's gone is gone. Okay. Common use cases: UI events, for example, like button clicks, live sense of data, stock price feeds, and network streams. Analogy: it's like watching a TV show, like the old way. It says in here we have like turning into a live radio show. You hear what's on now, okay, not what was played earlier. Why use it? Great for real-time systems. Ideal, ideal when latest data matters more than history. It works well with the share of broadcasted data. So, okay, let's continue with our code demonstration about call publisher. Okay, as usual, let's create a flux type string. Let's call the books. Okay, flux. It's going to be quite similar like before, so we can copy this. Yeah, sure, why not? Okay, then what do we have? I'm sorry. Let's use this method, unsubscribe. We know how to use that method already. Unsubscribe, and here we have subscription and starting. Let's call this starting new book delivery. Okay, just like that. Then our next method will be do on next. Do on next. Okay, let's create our lambda expression here. And let's print this preparing a book. Let's send the book. Okay, simple as that. Okay, after that, what do we have? Let's create our first customer. Okay, our first customer will be customer number one. Customer one. Okay, customer one, we need to subscribe now. Books, subscribe, and call book that, and then customer one gets book. Okay, we know. Okay, first of all, we are going to see start the new book delivery. After that, preparing book, clean code, then customer one. After that, finally, customer one gets clean code. Okay, and of course, all the books. Let's see this. Mhm. Customer one, he is starting new book delivery, preparing book. Customer one, preparing book. Okay. Let's create our second customer. Okay. This guy subscribe later. However, he gets the full list. The full list of books. Again. So we don't need. We just need to copy this. Okay, this will be customer customer two also. Okay. So let's print this. Let me clean and let's print this. So customer one and customer two, they both are gonna get the full list of books. It doesn't matter if customer two he subscribed later. Okay, it does not matter. We see the customer two, he's getting already clean code, effective Java, and design patterns in Java. All three books. Okay, let's continue with Backpressure. Okay, Backpressure is a Really important core concept in reactive programming. It lets the subscriber control the flow of data by telling the publisher how much you can handle. Okay, we as a subscriber, we're in control of the flow of data. Okay, we tell the publisher how much we can handle. Why backpressure matters? Prevents fast producers from overwhelming slow consumers. Prevents fast producers, uh, fast producers from overwhelming slow consumers. It avoids high memory usage from too much buffering, drop messages if buffers overflow, slowdowns, or even crashes under load. Okay, how it works? A subscriber uses the request method. Okay, subscriber uses request method to ask for a specific number of items. Publisher respects that request and sends only that many. It's like telling the waiter, please bring me 2 dishes at a time. I eat at my pace. Okay, let's see back pressure in action. As usual, let's create our store string. Okay, let's call the book string. And let's create flux just. Let's call this book A. Let's create 5 books. Okay, book A, book B, book C, book D, and finally book A. Okay, so this is our bookstore. Bookstore. Okay, and then we need to subscribe. Let's create a custom subscriber. Custom subscriber. Okay, in this case, it will be the reader. Okay, the reader. Okay, and the reader wants one book at a time. Okay, so we need to subscribe. Subscribe. Okay, new base subscriber. Okay, now we are going to override some methods. The first method will be hook on subscribe. Override methods. Hook on subscribe. Okay, this one we are going to print here reader subscribe. Subscribe is asking for one book. Okay, that's it. And now we need to use the request method. Request method. Okay, this method means it's asking for the first book. Okay, good. Let's override our second method. The second method will be hook on next. Override methods hook on next. Okay, hook on next. We're going to call this book. And what are we going to do in here? We're going to print the reader is reading, sure, reading what book, the name of the book, right? Okay, one book. And then after that, is asking for the next book. For the next book. Okay, great. Let's create a space in here, line space. Okay, then let's try to simulate the reader is taking like some time to read the book. Okay, that's why we need to thread sleep. Let's sleep. Uh, 1 second. Okay, let's sleep. Okay, here exception. Exception prints get message. That's it. Okay, after that, let's print done reading. Okay, because the reader has already finished the book. Okay, uh, done reading book. Okay, I think I got confused in here. We need to print this at the end, not in here. Sure, here. After reading the book, yes. So the reader is reading the book. After 1 second, he has already finished. After that, he's done reading the book and asking for the next one. Okay. Finally, let's go to the other method, hook or complete method. Okay, this will be quite easy. All books read. That's it. So what are we going to do? What are we going to see first? Okay, we're going to see reader subscribe, asking for one book. So that if requesting for one book, okay, we go to this method, hook on next method. Okay, reader is reading book A. Okay, after 1 second, done reading book A, asking for the next book. Okay, so let's see this in action. Great. Okay, I see the error. We need to request one book because we have not requested. Uh-huh. Okay, let's see again. Now we see this. Great. So what's going on here? Okay, let me explain you. The publisher is a bookstore. Okay, the publisher has 5 books ready to go. 1 book, 3, 4, 5. Okay, after that, the subscriber. Who's the subscriber? The reader. The reader is only asking from 1 book at a time. Okay, using this method, request method. Okay, so this is backpressure in action because the subscriber controls the flow. Okay, the subscriber is the one who controls the flow by requesting 1 book at a time. Okay, even if the publisher is fast, it doesn't matter. It waits for the subscriber to request one more book. Okay, summary. Here's what we have left. Reactive streams are lazy. They only start executing when a subscriber joins. Cold publisher. Each subscriber gets its own independent data stream. Hot publisher. Data is shared and broadcast live to all subscribers. Backpressure, which means flow control. Let subscribers limit data rate to prevent overload. Thank you so much.